Okay, this video is about vector operations. So keep in mind our friend little Vector from Despicable Me. He's going to guide us through as we learn about a vector. Okay, what is a vector? Okay, a vector is a quantity that has both a magnitude and a direction, like speed. You can go how fast and what direction. You need to know both of those. And a force, what is the force and what direction is that force being applied? So a vector looks like basically a good old ray, a beginning point and an ending point with an arrow. Now, the initial point where it starts, let's just call this P1, P2. So P1 is like your X value, P2 is like the Y. Terminal, let's call it Q1, Q2. All right, Q1 is like X, Q2 is like the Y. All right, so you have an initial point and a terminal point. Okay, I want you to know those two things because that'll help us know what direction it's going in. Now, we said P1 is like X and this is like a Y. So instead of using X and Y terminology, we use horizontal component and vertical component. But vertical is your Y, horizontal is your X. And that should make some sense. Okay? Notation-wise, vectors are written like this with a little arrow above them. And you will see as we do notation here in a minute, it's going to have this little, okay, that'll be our component vector, which I'll show you how to find in a minute. And later on we'll talk about magnitude, and that's just written with double bars, okay? And I will show you how to find that. Magnitude is how fast or how much pressure is applied, blah, blah, blah. All right, so component form of a vector. It's kind of a summary of the initial and the terminal end. So a vector could be anywhere on the quadrant plane, anywhere out there. It could be going anywhere. The component form gives us a version of that vector that starts at 0, 0. So it could be drawn from here out or wherever, but it starts at the origin. So it's rewriting the vector with an initial point of 0, 0. That's the whole point of a component form, and you'll see the value of that in a little bit. But how to find it? Well, if the initial point is P1, P2, that's your X and your Y, the terminal point is Q1, Q2, then the component of the vector is P2 minus P1, so the terminal minus the initial X, and then terminal minus the initial Y values, yielding the vector V1, V2. So it's the summary difference of your X's, difference of your Y's. And we use these brackets to prove this is the component form, so I can then draw it from the origin. All right, and that'll be very helpful in a little bit. So let's just try one of these. If the initial point is at -3, 5, the terminal is at 2, -4, write the component form. All right, so I'm going to take, this is the initial, this is the terminal. So always start with the terminal. So 2 minus -3 becomes +3. And then -4 minus 5. So let's add this, boys and girls. 2 plus 3 is 5. -4 minus 5 is -9. So my component form is this. Now, graphically, what that means is if I find this point out here, +5, -9, that's the terminal point of my component vector. So this is what it would look like when I draw it, because the initial point of any component vector is 0, 0. All right? All right, to calculate magnitude. Magnitude is the speed or the force, or usually it's a speed type of quantity. How do you calculate that? Well, remember, to find component form, we use differences of our x's, differences of our y's, right? And that gave us V1 and then V2. Well, look at that. If you draw that into a given vector, the differences in your x and your difference in your y's, you're going to create a right triangle. And how do you create a right triangle? Well, you're going to get, magnitude looks like this. Remember this? Magnitude is this thing. So how would you find the hypotenuse, basically, of this? Well, it would just be Pythagorean theorem. So magnitude squared would be V1 squared plus V2 squared. Well, I don't want the magnitude squared. I just want magnitude as is. So I'm going to take the square root of V1 squared and V2 squared. Okay, that's the whole gist of how to find a magnitude. You have to start with component form, then to calculate magnitude. So an example problem. If the initial point, I'll mark this initial, is 2, 7, the terminal is 1, -3, write the component form of the vector and find its magnitude. So component form first, okay? Remember, start with terminal and subtract the initial. So 1 minus 2, and then negative 3 minus 7. Well, 1 minus 2 is negative 1. Negative 3 minus 7 is negative 10. So my component form is negative 1, negative 10. Done. Magnitude is going to be the square root of negative 1 squared plus negative 10 squared. Well, that's 1 plus 100, so it's the square root of 101. And if I plug that in my calculator, I get 10.0. You're going to round to 1 decimal, okay? Everything needs 1 decimal place. Even if that decimal is 0, you need to round to 1 decimal. And that'll make life simpler as we go along. All right, so that's how you do magnitude. That's how you do component form. Now, how do you find the direction that the angle is going in, like the course on which it's on? Right, finding the component form of the vector, using the component form of the vector. Remember, it has to look like this, v1, v2. You can find the angle using tangent. Okay, so remember, here's our vector. Here's v1, v2. Theta is this angle right here. Okay, at the origin, remember? Well, this is the opposite and this is the adjacent side. So the tangent of theta is equal to the v1 over v2, right? Remember when we've done this before, if you need to solve for the angle, you take the inverse tangent of v2 over v1. Sorry, that should be a v1. And that is going to give us theta, right? So hopefully that makes some sense. So let's do this. Find the angle of direction of the vector given the component form negative 5, 3. So first thing I need to do is draw a reference triangle. Remember, one corner of a bow tie. Plot this point at negative 5, positive 3. Negative 5, positive 3. So here's that terminal end. Remember, component form allows me to draw from the origin. And it does matter where you draw this triangle, very much so. So if negative 5 is my horizontal component, 3 is my vertical component. And theta, remember, always is at the origin. So what I'm looking at is the tangent of theta is equal to opposite over adjacent, so 3 over negative 5. So to find the angle, I need to do the inverse tangent of 3 over negative 5. So using your calculator, making sure it is in degree mode, you're going to hit second tangent and 3 over negative 5. And I get the angle negative 30.96. Now, this is just a reference triangle. So if it comes out negative, disregard the negative. Just think, okay, that's 30.96 degrees right here from the x-axis, okay? 30.96 degrees. But I can't report my angle as that. Remember, we have to name our angles from standard position starting here. Our angle has to go all the way around. So in order to find that angle, I'm going to do, since this is in quadrant 2, I'm going to take 180 and subtract 30.96, and that'll tell me what the actual angle or course of direction is. All right, 180. So my actual angle, theta, will be 149.0 degrees. Okay? So be careful with that when you find your angle. You're going to get some reference angle, and that's the one that goes in your reference triangle. But then you have to consider what quadrant is it in. And so am I going to get it from standard position? Does that mean I need to subtract from 180? Do I need to add 90, 270? And as we do more examples, you will see what I mean. But it has to, the angle that you report at the end of the problem has to be measured from standard position, which is at 0. We'll try some more. Okay, let's do another one here. If the initial point is at negative 4, 6, the terminal is at 5, negative 9. First, write the component form, find its magnitude, and its angle of direction. Okay, so component form first. Remember, terminal minus initial, terminal minus initial. So my component form is going to be 9, negative 15. Magnitude, remember, is the square root of 9 squared plus negative 15 squared. If I calculate that, I get 17.5. So my magnitude is 17.5, all right? And then the angle. So I draw my reference triangle using component form right here. So it's a positive x and a negative y down here. So my vector looks like this. There's my reference triangle. The horizontal component is 9. The vertical component is negative 15. Theta is always from the origin. So I need to find the tangent, inverse tangent of opposite over adjacent. Remember this? Negative 15 over 9. Again, I get a negative 59.0 degrees. Well, remember, we're going to throw the negative out to make it positive 59, and then figure out what is that actual angle from the 0 degree. So if I measure it from all the way around, what would that be? Well, we know the full circle is 360. So if I take 360 and I subtract the 59, I'm going to get 301 degrees. I'm going to put my point 0. 301.0 degrees. Okay? So I hope that makes some sense. I want you to try it. You to try this for the WISC. I want you to find component form, magnitude, and angle. Good luck, and we'll see you in class.